Hello and good morning and welcome to this final part 3 video of Layer 3 MPLS VPNs. So the first two parts of the video, in part 1 we set up the MPLS VPN core, or the what's going to be referred to here shortly as we start to incorporate Ospf, the MPLS VPN super backbone area. When we initially started on Customer Edge 1 and 2 here at the top for Customer A, we went ahead and we configured BGP, and I've actually changed the AS numbers here. I had to restart my computer, and so I went ahead and redid things. But we're up and operational here, so we've got BGP AS 65039 on this side, and BGP 65 AS 65015 on this side, and in here we're still, or I should say we are now just BGP AS 100, right? But the focus of this video, the BGP piece, was for between Customer A sites, CE1 and CE2, and now we're going to look at Customer B's sites, right? And we're going to do OSPF between Customer B sites, and we're going to call his routers CE1 and CE2 as well. And we know that this is router 2 and router 4, which will be seen over here. So again, when we saw the second video, what we saw in the second video was how simple it is to actually use BGP as the PE to CE routing protocol for the redistribution of information across the MPLS Layer 3 VPN cloud. And not many options are needed. Simple redistribute statement on the customer side, and then you've got your BGP configuration that sort of blends in with the iBGP configuration that's already taken place for the MPLS Layer 3 component that allows us, or I should say the multi-protocol iBGP component that allows us to have the extended community sent between router 5 and router 9. So to go from, and let's change this to red here. So again, we've got that VPN v4 information that goes between router 5 and router 9. And we'll just say this is our VPN v4 and this is our VPN v4, where we send both communities. We send the standard communities and the extended communities. And the extended communities allow us to tie in our route distinguisher, right? As well as our route targets, so that we can differentiate the routes that are being sent. And so now we've got a single customer connected, and so the goal of this third and final video is to talk a little bit about OSPF as the PE to CE routing protocol and some of the idiosyncrasies that we need to be aware of when using OSPF. And we're going to take a look at specifically the domain ID. We're going to take a look at some of the configurations that you can use. You'll see we're doing area 0 on both sides here. And with that in mind, just a couple of images here. So we could do area 0 on both sides, remembering that the MPLS Layer 3 VPN super backbone, this is sort of seen as the top of the OSPF hierarchy. So we could have, between the PE and CE on either side, we could have area 0, right? We could also have non-area 0 areas on both sides. So, for example, up here, if I wanted to use area 51, we could do that, and I could use area 51 over here. And so that's what this image is showing you here. It's the PE to CE links with non-area 0 PE to CE routing protocol area set up. So the third option is we could actually have two different areas. And the reason that we can use two different areas, just like we could use 51 and 51, we can use 51 and 99 if we want. Because again, this is seen, it's not really an area, whoops, it's not really an area 0. Let me get the pin back up here. I guess we'll go with this lowercase a. It's not really seen as an area 0. However, the behavior of what takes place here, because these routers, the PE routers, are seen as autonomous system boundary routers, they're also seen as ABRs, right? So again, this is seen as one massive area 0. So just like with basic OSPF, I can have two non-area zeros. As long as they connect to the backbone area, we can exchange routes. And so that's what you're going to see here. So again, we could have two completely different areas on either side of the cloud for the customer, and this big MPLS super backbone is going to be seen as area 0, right? Okay. So that's another option you can go with. A fourth option that you could take a look at would be to have an area 0 on one side and then a non-area 0 on the other side. And the key here is that if for whatever reason you had an area 0 sitting behind it, and this is RFC 4577, if you look at section 414, it talks about the virtual link needed that allows inner area routes as AS external routes to be leaked between the PE routers and the non-PE OSPF backbone, right? So this would require a virtual link between the PE router and area 0 if this is what your configuration looked like. And then finally, you could have a setup where you've got area 0, right, on either side between the PE and the CE with any number of areas. And again, I could have put, area 109 and then over here area 151. As long as they're tied into area 0, we're okay, and that's going to work. So those are just a couple of options that you could use. Now obviously the purpose of this video is to get these adjacencies up and running. So this is going to be customer B down here. So we'll say customer B going this way. And what we're going to do is we're going to actually use the same, and I believe it's the 10.1.1.1, and I think I'm using 10.1.1.2, and we can check this. But what I'm going to do is I'm going to use the same IPs. I'm going to redistribute the same IPs into the MPLS core that customer A is using and customer B is using. And they're going to be the same to show that it's that route distinguisher that's going to allow us to have the same IPv4 prefixes propagate across the MPLS core as extended communities with that route distinguisher value, keeping it different from the other customers, right? And we're also going to be creating VRFs as well. So let's go ahead and take a look here. Let's jump back in. So right now, if I were to take a look at router 5, so we're on the left-hand side, and this is PE1. So if I were to say show run section BGP, let's see where we're at right now. And this is where we left off. Again, the BGP AS number has changed and the customer AS number has changed, but the configuration as a whole is the same as what it was at the end of video tutorial 2. So this begs the question, right? We have this address family IPv4 VRF for customer A. Well, now we're going to need a VRF for customer B. So let's go ahead and make that happen. So we'll go into global config, we'll type VRF definition, and I'm going to say customer B. So now the route distinguisher that we used, if I do a do show run on VRF, let's see what we have right now. So we used route distinguisher 100:1 for customer A, or we'll say customer 1. So here, let's use route distinguisher 200:2 for customer 2. And then I'm going to say address family IPv4. And within the address family is where I'm going to set the route target up to both import and export. And if I do a question mark, you can see we're going to use that same value, the 200:2. All right. So now if I type show run VRF, let's see what we have now. So we have the VRF definition for customer A right here. And now we have a VRF definition for customer B. Because again, on the PE router, what we're really doing is we're just carving the router up into virtual routers, hence the VRF, the virtual routing and forwarding instance. So now that we have the VRF set up, let's go ahead and apply the VRF to the interface, and let's configure this, and it's going to be this interface right here, this E01 interface, right, which is going to be tied into a VRF right there. So let's go ahead and make that happen. So we're going to say interface Ethernet 01, and I'm going to say VRF definition, or I'm sorry, VRF forwarding customer B. Now, if I were to do a do show run on interface Ethernet 00, you can see that, again, the configuration is very straightforward. So if I add the IP address here for Ethernet 01, it's going to be IP address 192.168 dot, and this is going to be 25.5, and it'll be /24. So now let's compare. There's Ethernet 00, and now what does Ethernet 01 look like? So again, these are sort of, at this time, right here, this snapshot, these are kind of protocol agnostic, right? So we have our VRF configuration, basically saying that this interface is part of the customer B VRF, and then we have our IP address, okay? So what do we need next on the customer side? So let's step over to router 2, and very similar to the configuration that we did on router 1, and let's do a do show run interface E01. We should have no configuration on there right now, and let's give it a second here. It's kind of hanging up on me there. Okay, there we go. So we've got no configuration on router 2, I should say. Sorry, we have no configuration on router 2. So let's go ahead and let's sort of set up router 2 so that he is ready to roll. So we're going to set up a loopback interface, and this is going to be one that we also redistribute here. So we'd say interface loopback 0. I'll say IP address, and before I do that, let me confirm on router 1. I do show IP interface loopback 0. So you can see the address is 10.111 and it's a /32. So we're going to do that same address. IP address 10.1.1.1, and we're also going to make it a /32, right? So now we have the same loopback IP configured on both. Now the difference here is going to be that we're going to go ahead and we're going to say IP OSPF, and for this side, we're going to use 25 as our OSPF process ID. And the reason we're doing this, it's kind of contrived, but it's going to allow us to see some of the different behavior that you're going to see with OSPF. So we'll say IP OSPF 25, and as I said, we're just going to use area 0, right? And so do show run interface E01, what does it look like? Oh, I'm sorry, do show run interface loopback 0. So that's what our loopback 0 interface looks like. So now let's go ahead and let's configure interface E01. So I'm going to say no shut, and again we're going to stick with our IP address convention, which is just simply 192.168 between the PE and the CE, and then the third octet is the lower router number to the higher router number, followed by, the router number. And so we've got that set up now. So let's see, do we have connectivity? If I ping from the CE to the PE, 192.168.25.5, and let's see if we've got any connectivity. So no connectivity right now. And let me actually double check over here. So 192.168, the interface is shut down, so let's say no shut. And let's run that again. All right, so we have connectivity between the two. So now what I'm going to do is do show run interface E01. We want to go ahead and say IP OSPF, and this is going to be process ID 25, and this interface will be placed into area 0. So let's quickly set up our router OSPF 25. We want to get our router ID set up to 10.1.1.1. We'll make it that loopback interface. We'll log adjacency changes. excuse me. And then we're going to leave it at that. So let's go back to router. Now there's no OSPF adjacency yet here. So if I say do show IP OSPF neighbor, we're not going to see anything, because while we have done some preliminary configuration here on the customer edge router for customer B, we haven't done any of the configuration for the VRF component here on PE1, or as we refer to it as router 5. All right, so we're using OSPF this time, right? We're not actually using BGP, so there's going to be a little more work that needs to be done at this point. And so the first thing that we're going to want to do is we're going to want to configure the OSPF on the PE router, right? So, and we're going to stick with the same areas that we have that we had prior, 25 I should say, that we configured on customer B's router 2. Now, it's a little different, right? So let's take a look. If I do a do show run on section OSPF, as you can see, we already have an OSPF configuration here, right? Because remember, we're running OSPF as the IGP that's facilitating all of our MPLS connectivity. So I can't do the customer configuration within the global OSPF config. What I need to do is I need to create a separate, mutually exclusive OSPF configuration that's going to be only for the PE router and only for the VRF, I should say, that interfaces with customer B. So we're going to type in router OSPF. We're going to use the same process ID 25, and we're going to make sure that they match on either side. And then there's that VRF keyword where I'm going to say customer B. And so what I'm doing now is I'm creating an OSPF process. However, it's mutually exclusive from the process that's running for the MPLS connectivity in the provider core. So in other words, the MPLS connectivity out interface E10 and E11. So what are we going to do here? Let's set the router ID, and we're going to go ahead and set this to the interface, the IP of the interface that we're using here. So 192.168, and this would be 25.5 is going to be his router ID. And let's turn on ISPF for incremental SPF. It doesn't really matter. And then that is going to be it for the OSPF config on this side for right now. Let me see. Let me step back over to router 2 here. So let's do show run interface. Oops, do show run section OSPF here. And router 2 is certainly taking its time. So as you can see, we've got area 0, process ID is 25, and we have our router ID here. And we've got OSPF running on the loopback interface as well as the physical interface. And then here, when I do show run section OSPF, we have, for our process, we've got the router OSPF 25 VRF customer B. So let's take a look at the interface, because I want to make sure I did not forget. I believe I might have. Do show run interface E01. And I did. So let's jump back into interface E01 and let's add in IP OSPF 25 area 0, right? So I forgot to add that in. I didn't see the adjacency come up, and then I was wondering if I'd forgotten that. So we've got that added in there now. So let's see what that do show run interface E01. So there we go, IP OSPF 25 area 0. You can see that the adjacency with 10.1.1.1 has now come up, right? And the adjacency is now in the full state. Okay, so we now have the OSPF adjacency configured between, and I'm sorry, customer 2 here, customer 2. So if I do a do show IP OSPF neighbor, you can see that now we have a neighbor relationship with the PE router. If I do a do show IP route, We haven't learned anything yet because nothing's being redistributed at this time. So let's go ahead and let's do that. Let's take care of, the BGP portion of this configuration. So I'm going to have to go back into, let me, one last command here. So it's going to be router Ospf, and I believe we use 25 for VRF customer B. And I want to redistribute because there's going to be mutual redistribution here. So before, when we used BGP, right, it was simply the redistribution of the connected routes from the customer side. So here, we want to make sure that we're going to redistribute out of the Ospf process. So we're going to say redistribute Bgp, and we're using 100, and we'll say metric. We'll give it a metric of, we'll say metric 9 and subnets. So we want to make sure that we're redistributing the BGP routing information into this customer B's Ospf VRF. So if I do the do show run on section Ospf now, you can see that here is what our Ospf section looks like. So let's go ahead and take a look at the overall BGP setup. Do show run section BGP. So this is where we left off, right? We haven't actually made any changes here to the BGP AS100 setup. We've got our neighbor relationship with the other PE router, router 9, and we have our IPv4 VRF definition for customer A. So let's go ahead now and add in the information for customer B. So I would say router BGP 100, and then as you can see, where am I going to make that addition? It's going to be, again, IPv4 VRF, and we are dealing with customer B, right? So there is really no information that with respect to the BGP family, there really is sort of no information that we're going to, it's not BGP information that's being shared back and forth. This is actually going to be the VRF information for the customer. So we're going to say out of the, let me make sure I get this correct here. So out of this, it's not a neighbor relationship. We're going to be doing a redistribution. So we'll say redistribute Ospf 25, and we're going to say VRF, or actually not the VRF. We're going to say match, and what are we going to match? We're going to match all of these routes because this is going to determine which routes are getting redistributed. So we've already done the redistribution statement to redistribute BGP into Ospf. Now we're going to redistribute Ospf into BGP, but what kinds of routes do we want to match? So we want to match all of these. We want to make sure we get everything. External, right, type 5s, internal, type 3s, and then the nssa externals, which are our type 7s, right? So we want to make sure that we're matching all of those routes when we do our redistribution. Okay, so now if I do a do show run section BGP, what does it look like? It looks like this right here. So here's our address family IPv4 for the VRF for customer B. And what are we doing? We're simply going to be doing the redistribution, right, of Ospf process ID 25. And we're going to be matching any internal routes, any external routes, type 1, type 2, nssa, right? So we're making sure we've got all of our bases covered with respect to the redistribution. So if I were to say do show IP route VRF customer B here on the PE router, what do we see right now? So interestingly enough, we see that we're already picking up the 10.1.1.1, which is the loopback IP address off of the customer B CE1 router. Now if I do a do show IP route for customer A, we are also learning the BGP a BGP route, which is 10.1.1.1. So here you can clearly see that with the VRF setup, it's possible for us to have the same IP subnets or IP prefixes learned via different processes. So we've got Ospf picking up the 10.1.1.1 here from customer B's router 2, and then here it's picking up a BGP route with the exact same IP address, learning it from BGP, but it's in a different VRF. And so then that is okay. All right, so we're going to leave the left-hand side here, the PE1, CE1 side for customer B, and now we're going to come over to the PE2, CE2 side. So let's do a do show run section Ospf here. So we're going to come over to this side. We're going to hit router 4, and I believe there is no configuration right now on router 4. So let's go ahead and we're going to put a loopback address on here. We'll say interface loopback 0, and we're going to make it the same 10 dot, and actually let me confirm that on router 3. So let's see, show run in loopback 0. So we're going to make it 10.3.3.3. All right, so we'll do 10.3.3.3 on router 4 here, which might be a little awkward because it's router 4, but we're going to use it. So 10.3.3.3, and we're going to make this a /32 as well. All right, and we're also going to say IP Ospf. Now the area on this side, we're going to use 49. Not the area, the process ID, we're going to use 49, and then I'm going to go ahead and say area 0, right? So now let me go ahead and go into router Ospf 49, and we're going to say router ID is going to be 10.3.3.3. We're going to log adjacency changes. Sure, we'll turn on ISPF for incremental Ospf, and then we are going to say interface E11. We're going to do a no shut on the interface. And now we're going to go ahead and configure this interface as it would be configured to communicate with router 9. So IP address 192.168.49.4, and this is going to be a /24. We're going to say IP Ospf 49 area 0 to make sure that this interface gets added in, and then let me confirm. Yep, and that is going to be it. Let's make sure that just want to confirm we've got the same settings. Do show run interface E01. Yep, and that is it. So we are good there, right? And let's go ahead and at this point, excuse me, at this point we're going to configure router 9 so that it looks like router 5. So again, if I do a do show run section Ospf, you can see that we're going to need a VRF done. So let's create the VRF first. So we'll go into global config mode here, and I'm going to say VRF definition, and this is going to be customer B. The route distinguisher, we're going to use the same one, 200:2, and then we're going to say address family, IPv4, and we're going to use the same route target. So we're going to say route target. We're going to do both. If I back up, it's whether we're going to import or export it. So we're going to do both, and I'm going to say 200:2 for customer 2. So do show run VRF. What do we see? We have our VRF definition here for customer A, or I should say, yeah, for customer A, who's 101, and then we have our VRF definition here for customer B, which is 200:2. So now we can actually configure the interface here. So let's go into interface E11, and we're going to say no shut, and we're going to say VRF forwarding, and it's going to be for customer B, right? So what do I want to put on here? Well, let's get an IP address on here. So the IP address would be 192.168.49.9 /24, and then we're going to say IP Ospf 49 area 0 on that interface. So let's see, do we have connectivity? 192.168.49.4. Oh, and I need to ping need to ping the VRF. Sorry about that. Well, we do have connectivity. The adjacency came up, but I'd be looking to do a do ping, and it's going to be VRF customer B 192.168.49.4, and there we go. So we've got connectivity, which unfortunately I forgot to add the VRF because we're on the PE router. If I'm on the CE router, which is router 4, I don't need to do the VRF. I can say do ping 192.168.49.9, and obviously we have connectivity because the OSPF adjacency did come up. So let's go ahead and say do show IP route here on the customer edge router, and let's see what we've got. So again, we haven't picked anything up from OSPF yet, but that's because we haven't redistributed anything yet. So let's go back into router 5, whoops, I'm sorry, router 9, and we're going to now go ahead, if we do a do show run section OSPF, you can see we have our router OSPF 49 for VRF customer B, and now we're going to go ahead and configure the redistribution, and let me make sure I get in here. So we'll say router OSPF 49, and that is, whoops, not what I wanted. So we'll say no router OSPF 49. I forgot left my VRF off of there. So router OSPF 49 VRF, and it looks like I took it down, VRF customer B. So we get to do the bonus lab here, which is set this up one more time. So we're going to say router ID. We'll make the router ID the interface that we have there, which is going to be 192.168.49.9, and we'll log adjacency changes between the neighbors. So if I do a do show run section OSPF, you can see that here's my router 9 VRF customer B configuration. If I'm on router 5 and I do show run section OSPF, you can see they're going to be very similar for the VRF definitions, right? And now we want to make sure we get our redistribute statement in there to redistribute the BGP into the OSPF. And so let me add this in there. All right, so now what do we look like? So here we go. We've got our router OSPF 49 VRF customer B, and we've got our redistribution statement. So let's make sure, let me do a do show run interface E11, and it looks like it pulled the OSPF definition there. So let's go into interface Ethernet 11, and I want to say IP OSPF 49 area 0. So when I did the no router OSPF 49, it pulled that off. So we're going to add that statement back in there, and let's go ahead now, and the adjacency is back up. So if I come over here to router 4, you can see the adjacency is back up. If I do a do show IP route, what do we have now? All right, well, this is actually fantastic news. So what do we have here? So we have 2 type 5 routes that we're learning about, right? We're learning about 10.1.1.1, right? And it's showing up as an external type 2, right? So you can see where are we at? Where are the E2s at? So here we go. E2, OSPF external type 2. Now this will be the default behavior when the process IDs are different on both sides, or on one side or the other, right? So we're using process ID 25 on the PE router, PE1, but we're using process ID 49 on PE2. So we're going to see these as external type 5 routes, but as you can see, it looks like we've got connectivity. So what if I do a do trace 10.1.1.1, and I'm on the customer edge 2 router here for customer B right now. So I'm tracing over to the loopback that's here on the customer 1 router. So obviously the first hop here again is going to go into router 9, and then we time out, right? Or we have no visibility into the rest of the route. So it looks like we may have a slight issue here that we're going to have to troubleshoot. So if I were to say Control-Shift-6, if I were to try to ping 10.1.1.1, let's see what happens. So we're picking up the route, but we're not able to ping from one side to the other. Now, what did we not do on router 9 that we did on router 5? And it's actually should be that huge line right there should be pretty obvious. So let's do a do show run section BGP. So what have we not done? So we're picking up the route, however, we haven't added in our IPv4 VRF statement for customer B that's going to allow us to redistribute the route. So if I come over here to router 2, do show IP route, what do I see? So you'll notice that we didn't do the redistribution yet on, where's my pin there? We didn't do the redistribution yet here on router 9. So we're not redistributing, so no redistribute, right? Which means that we're not redistributing OSPF into BGP, so therefore CE1, he doesn't see anything. He sees no OSPF information. However, remember, on router 4, we get these routes, right? Whoops, I didn't want to shrink that. I wanted to highlight it. So as you can see on on CE2 for customer B, he does get these routes. And the reason he sees these routes is because on router 5, we went ahead and added in our redistribution of the OSPF information. So right now, what do we have? We have sort of one-way distribution. We're redistributing from router 2 over to router 4, right? And that's going through router 5 and router 9, but we're not doing it the other way. And the problem is right on the CE router, right? So we have the redistribution statements here on router 5, but we're missing those on router 9. And this is what you'll see if that's the case, is that we get the information, whoops, where's 4? We get the information on one side because we're redistributing that way. However, on the other side, we are not redistributing, right? Or we're not receiving the redistributed routes because we need to set that up here on router 9. So let's knock that out right now, and we'll go into the router BGP 100. We're going to say address family IPv4 VRF for customer B, and now we want to add in those same statements that we saw. If I were to do the do show run section BGP, we want to add in the same statement here so that we can redistribute. And again, it was redistribute, and then you pick your routing protocol. For us, we're going to redistribute OSPF. What is the process ID? Well, it's 49. And then what are we going to match, right? What do we want to match? We want to match externals, type 5s. We want to match internal, type 1. And we want to match type 7 NSSA externals, right? So now we've got that redistribution statement. Let me quickly move over here, not router 1, router 2, and let's rerun this command and take a look there. What do we now have? We now have the information that has been redistributed from OSPF on the provider edge 2 router, router 9. We've redistributed the OSPF information that we matched, which was type 3, type 5, and type 7s, into multi-protocol IBGP, and it goes across that MPLS core, that cloud, and is then redistributed again from BGP into OSPF, and it comes out on the customer edge, the customer B CE1, which is router 2. So now let's check and see, do we have end-to-end connectivity? If I do ping 10.3.3.3, all right, now we do have end-to-end connectivity. Let me try again over here. Can I now ping to 10.1.1.1? I can. So let me see what happens if I try to trace now. So do trace 10.1.1.1. and let's see what happens now. And we'll give it a second or two here. And while that's going, I would like to clear this layer, but I'm not sure. Okay, that gives us a much better picture. So now we're going to trace, and let's see what happens now that we have sort of our end-to-end connectivity. And there you go. As you can see, we've got our MPLS label, which is going to be that, whoops, and that is not the MPLS label. So we've got our MPLS label here, which is 604. So the packet comes into router 9. Our first hop is 49.9. And let me clear these guys out here. So now that it's done, I'm going to go ahead and start writing. So the first hop is 49.9, right? And we make that hop. But then we have label 604 imposed onto the packet, and it goes out to router 6. 510, this is our VPN v4 label, right? This is going to identify the VPN on the other side into which this traffic, which is just ICMP, is going to be placed. So based off of that, when I get to router 25.5, which is router 5, router 5 takes a look at looks at this and says, label 510, that's a VPN v4 label. This traffic goes to customer B. Just like we saw, I believe it was label 508 that was in play between router 3 and router 1 when it would make its way across the MPLS cloud. 508 was the tag being used by that traffic in the second video tutorial. So as you can see, customer B's traffic gets label 510. So when that hits the PE1 router, in this case, it's going from right to left, the PE1 router says, okay, well, label 510, that's my VPN label. I know exactly where I'm going to dump it. I'm going to dump it into the VPN customer B for customer 2, or customer B is what we're calling him. Okay, so let's clear our screen there. So now we have end-to-end connectivity. However, we've got this interesting sort of output here where we're picking up type 5 routes, right? External type 5 routes. And those routes are not very preferable when it comes to Ospf. And specifically, let me change this to red. Specifically, if I had a backdoor route of some kind here, right? Or let's just, I guess I should draw it in solid. If I had a backdoor route of some kind, or a backdoor link, this backdoor link will be seen as intra area, right? And here's the thing, is that intra area routes are always preferred over inter area routes. And so, and that's irrespective of cost. So if I had an intra area link and the cost was $65,535, the maximum cost for Ospf link, it would still be preferred over an inter-area link with a cost of 9, right? Because intra-area is always preferable over inter-area. Now, we don't have this backdoor scenario here right now. So this doesn't exist right now. But if it did, right, you would want to do what's called a sham link. And there's another video that I have up that actually walks you through this. It goes through multiple failure scenarios. So always a good one to take a look at if in fact you do have a backdoor link. But we don't have that, but I wanted to make sure I covered that because intra-area routes are always preferred over inter-area routes. So remember we had used process ID 49 over here and 25 over here. And specifically, it's when we set it up on the PE routers, right, that we have different process IDs. So I might not want these to be seen as type 5 LSAs. And why is that? Well, remember that I can't summarize a type 5, and I also cannot send a type 5 into an NSSA area. So if maybe I've got an NSSA area hanging off back here, you know, off of router 4, and let's say this is router 11 for whatever reason, and this is an NSSA setup, that type 5 is not going to make his way down to router 11, which we might want. So what we're going to do here is we're going to set what's called the domain ID. And the domain ID gets set under the VRF Ospf process on the customer edge routers, and we want it to match. And as soon as I match it, what we're going to see is these type 5 routes are going to change and turn into type 3 summary LSAs. So let's go ahead and do that. I'm going to say router Ospf, and I need to take a look here. I think it's, yeah, 25. So router Ospf 25 VRF customer B. And so let's go ahead and add in the domain ID. And as you can see, we can put in null, a type, or domain ID and IP address format. So this is customer 2, so let's use 0.0.0.2. So I'm going to set the domain ID on this side. Let's do a quick check. How do I see these routes? Do I still see these routes as type 5s? I do, over on customer B's router 2. How about customer B's router 4? How do I see these routes now? Still see them, because again, the domain IDs do not match between the PE routers for the Ospf VRF process. So now let me jump on to the second PE router, PE2, which is router 9, and let's do that same thing. So we're going to say router, and I need to, I think it's 49. Yeah, so router Ospf 49 and VRF customer B. And now let's take a look and see if we set the domain ID to 0.0.0.2, because again, we're saying that this is customer 2. I'm going to hit enter here and then quickly make my way over to router 2. And so let's do the do show IP route, and let's see how long it takes Ospf, now that the domain IDs match, to change those routes from E2s to IA. And so that's what we're looking for, is we're looking for an inter area, but again, it's going to be a summary type 3 LSA, which would be preferable to what we're getting right now, which is the type 5 LSA. And look at that, there you have it. So again, if the process IDs on the PE routers for the VRFs in question, for the customer VRFs in question, do not match, and here they don't. We did 25 and we did 49. If they do not match, you're going to end up with type 5 LSAs, right? So E2 routes. If they do match, and you can force it with that domain ID command configured under the VRF configuration for the specific customer on the PE. You'll notice we're not changing anything on the CE router here, right? So the heavy lifting, again, is really the responsibility of the service provider. So nothing changed on our customer edge routers. However, we're auto-magically picking up type 3 LSAs now. So these inner area type 3 LSAs. Now, a quick comment on that backdoor scenario that we just talked about. If that link was there, that link is still going to be preferred, because again, that would be an intra-area route, and you can clearly see that even though it's a type 3, these are still inter-area routes. And so the intra-area routes are always more preferable than the inter-area routes. Excuse me. All right, so we've been able to see now that how to change the routes from type 5 to type 3s if the process IDs on the PE routers for the customer in question, his VRFs, if they don't match, this is how you would do that. So what if I do a do show BGP VPN v4 Unicast all, oh, I'm sorry, want to be on the BGP or on the customer edge router. So do show BGP VPN v4 Unicast all. And so what do we see here? Right now we have two customers, and this actually gives us a pretty nice picture. So I'll highlight this information here. You can see we've got the route distinguisher 101, and we know that that's for customer A. Now we've added customer B in here, and we've got his route distinguisher, and it clearly delineates the customer A information from the customer B information. And what's even nicer is you can clearly see as well that they're using the same IP address prefixes, right? Or the same route. So you got the 10.1.1 there, and you have it down here. And the same thing, you've got the 10.3.3.3 here and the 10.3.3.3 here for customer B, right? And so this allows us to see that not only can you have multiple customers, but if for whatever reason those customers were using the same information, the same routing information, IP address space information, that even though they're using identical information, that information is separated or segregated, if you will, from each of the customers' different information, each of the customers' information. So on the PE, let's do. So I'll do a do show VPN v4, and now we're going to take a look at the specific VRF in question, specific route. So VPN v4. I need my BGP. BGP VPN v4 Unicast VRF, and our VRF, we'll take a look first at customer A, and we're going to say, let's look at the 10.1.1.1. So as you can see here, remember customer 1 is using BGP, so customer 1 is not using Ospf. So we have, what's the extended community that we need for BGP? Very straightforward, right? The route target. There it is, 100:1. And that's the extended community attribute that is getting exchanged between the PE routers. Now, what if I take a look at that same information, and let me make sure, definitely an unknown VRF there. So let's get that right. All right, now let's take a look at the BGP information and take a look at the extended community information for BGP. I'm sorry, for Ospf. So, and actually, let me just highlight it right down here. So this is some great information right here. So what do we have? We have our route target, which we set up as 200:2. We have our Ospf domain ID, right? So this right here is the value for the domain ID. And what did we set our domain ID to? Remember, we set it to 0.0.0.2. So what if I were to tweak that? What if I were to say domain ID, and if I wanted to change it to 0.0.0. and we'll do 10, because 10 in decimal is equivalent to A, the letter A, in hexadecimal. And so let's see. So I'm going to make the same change on both sides. And we've done it on one side, so let's watch. Let's see what happens here. So now, whoops. So now and that was rather quick, right? Take a look at that. So it changed it from type 3 inner area, right, LSAs, to type 5s right away, back to E2s. Okay, and let's make sure over here on router 4, is he seeing the same thing? And he is. So look at that. As soon as I changed that domain ID so that it didn't match, they went right back to type 5s. All right, so let me come over to router 5. We know the command that we need to run. Actually, we ran on router 5. Come over to router 9. Let's match them up. And let's see how quickly Ospf is going to bring that back online as an inter-area type 3 LSA, not an external type 5, which is what we're getting right now. And that's why you see that OE2. So the domain IDs have been set to match again. And I could force it. I could probably do a clear IP Ospf proc. However, I'm going to try to be a little patient here and let it work itself out. Probably about 5 more seconds to go. All right, come on, Ospf. let me make sure I set them to the same value here, that I didn't miss something. So no, domain ID is right. And let me do show run section OSPF. Let me make sure that I only have a single domain ID statement. Okay, good. All right, so let's jump back over here to router 2, and there we go. All right. Took a little longer than I had hoped, but again, the end result is what we expected. Now we're back to these type 3 LSAs, these inter-area routes instead of external routes. So back over here, where before we saw the 02 as our value, let's go ahead now and run that command again for customer B, and what do we see? 0A. And so this is the extended community that's used by OSPF to determine whether the domain ID matches, right? And then you've got the route type down here, where you've got the quad zeros, :2, :0. And then we have the OSPF router ID that we selected. And again, there is our label, right? The VPN v4 label that would be inbound would be 510 if it's destined to that network. Now let's take a look at 10.3.3.3 from router 5's perspective, PE1. And what does he see? Sees the same thing, right? So there's the 0A, which is equivalent to the decimal number 10. And you can see if it's going, the outbound label it's going to get is going to be label 910 from router 5. And so then that would come out from router 5 going over to router 9. All right. So again, this is where you see that domain ID value, and by us just tweaking it and setting it the same and then, changing it to a different value, you can clearly see that that is how this information gets manipulated here. Okay, so we have end-to-end connectivity for both of our customers. We're redistributing OSPF into BGP. We're also redistributing BGP into OSPF, and that is probably where we're going to wrap this video up. We've tweaked the domain ID. We talked about the backdoor link, and when you introduce that, that introduces some other complexities. Again, I have another video on that. And so this pretty much wraps up our MPLS Layer 3 VPN 3-part series. We did BGP as the PE to CE routing protocol. We did OSPF as the PE to CE routing protocol, and took a look at some of the little idiosyncrasies with OSPF, specifically the domain ID and when we go to redistribute and what ends up happening. So again, I really appreciate your time. I know your time is valuable, and I thank you for watching, and hopefully this has given you a much better idea as to how you would set up Layer 3 VPNs with OSPF and BGP as the PE to CE routing protocols. All right, thank you so much for watching, and have a great day.